In this presentation we are discussing about International Thermonuclear Experimental Reactor. International Thermonuclear Experimental Reactor is an international nuclear fusion research and engineering megaproject, which will be the world's largest magnetic confinement plasma physics experiment.
ITER is located in Saint-Paul-les-Durance, in Provence, southern France. The project is funded and run by 7 member entities: the European Union, India, Japan, China, Russia, South Korea, and the United States. The EU, as host party for the ITER complex, is contributing about 45% of the cost, with the other 6 parties contributing approximately 9% each. ITER inspired by the fusion power of Sun. Imagine what it would be like to have a miniature version of our Sun right here on Earth. Would it give us an infinite supply of clean energy? Would we get rid of coal and nuclear power plants? Could this energy replace the rocket fuel? Could we control it? The Sun is an enormous amount of nuclear fusion generator. Every second it fuses 620 million tons of hydrogen, and forms into 606 million tons of helium in its core, and releasing a vast amount of energy in this process.
To create a replica of the Sun on Earth, we need to squeeze atoms of hydrogen hard enough to make them fuse, but this fusion is only possible at extreme temperatures. Even the Sun's coldest part, its surface, burns at an incredible 5,500 degrees Celsius. Not even a spacesuit can protect you from that kind of heat, but we could engineer a high-temperature superconductor to tame our scorching mini-sun. Having an artificial sun on our hands would provide us with almost limitless amount of energy. Of course, it would be much smaller than the Sun. To make it work greater than, we need 2 specific hydrogen isotopes, one of them called deuterium, we'd extract from water, the other one tritium, we'd brew from lithium during the fusion reaction itself. Greater than with the help of huge magnets at least 1,000 times more powerful than those in fridge. This field would keep the artificial sun in place. While we're heating it up to 150 million degrees Celsius, few materials could handle the scorching plasma of our Sun. We have to create a robust blanket for it, one that wouldn't melt during this scorching fusion. Once we had all the engineering issues figured out, the artificial sun would completely change the way of our energy system works. Fusion reaction. When deuterium and tritium fuse, 2 nuclei come together to form a helium nucleus, an alpha particle, and a high-energy neutron. The energy released as heat is used to produce steam, that force-run turbines and generate electricity. Advantages. Asterisk, it would produce 10 times more energy than what it consumes. It wouldn't emit any greenhouse gases, and there would be no hazardous radioactive waste left. We'd never run out of hydrogen because most common element in the universe. Asterisk, the deuterium-tritium fusion process releases roughly 4 times as much energy as uranium-235 fission, and million of times more energy than chemical reactions such as the burning of coal. Clean and green energy. The byproduct of this fusion releases helium. It's inert gas and non-toxic, nature-friendly gas. With this clean and safe source of energy, we'd stopping adding fuels to climate change. Clean and green energy. Thank you. And subscribe to watch more like videos.